A good day to you, grade 12 learners. Welcome to today's physical sciences lesson brought to you by the Northern Cape Department of Education in collaboration with Agama Research and Development. My name is Davezinhle Liwayo. In our lesson today, we want to look at our paper one revision, that is for our physics section of our examinations. I hope you are ready. I hope you are geared and excited to start our lesson. And as I'm saying, it's our revision, so ensure that you have all the materials that you need as we take part in this revision segment. And I urge you to take part actively as an individual. So when you carry out the calculations, ensure that you carry out the calculations yourself so that you are able to take note of the places that you actually need more help. And since we'll be looking at these past examination questions, I'd like to say all the best as we do the questions together. All right. We're approaching our examinations and we're saying time is ticking, so we need to make use of our time. So we're saying at the end of this lesson, you should be able to attempt typical examination questions in the paper one, that is your physics examination. So what is our pre-knowledge? So for you to be able to attempt your paper one questions, the ones that we know that we know that our paper is out of 150 marks, all coming from these different sections. So you should have some background knowledge on the mechanics section, which constitutes about 65 marks of the whole paper. So you can see this is a broad section. It accounts for many marks. So we need to perform well in that particular section. And remember, when we're looking at mechanics, we're taking of topics like, number one, we're talking of momentum and impulse. I hope you do well to remember the concepts that are involved when we're talking about momentum and impulse. We talk of the vertical projectile motion. We also talk of Newton's laws. I hope you still remember your laws from law number 1 to number 3, and even the law of universal gravitation. And then also we talk of work, energy, and power. Those are the concepts that we find in our mechanics section. And I hope you have done so much work up to this stage on those sections. And then the other section that we have when it comes to your physics examination is waves, sound, and light. And here we're talking about the Doppler effect. Yes, the Doppler effect. I hope you are able now to describe the Doppler effect. What do we mean by the Doppler effect? Remember, we're looking at the changes in the pitch as our sound source actually moves. It's either towards our listener or away from our listener. And you know the calculations that are actually involved there. And we're saying this accounts for about 15 marks out of the 150 marks in our paper. Electricity and magnetism, yes, that is also a broad section. You can see there it counts for about 55 marks, right? And in our electric circuits, remember, in our electricity and magnetism, remember, we're looking at our electric circuits. Are you able to do the calculations there concerning our electromotive force, our internal resistance, our external resistance? Are you able to do those calculations, right? So looking at the electric circuits and even our electrodynamics. Remember those sections. And we're saying this counts for 55 mark of our paper one. And looking at these three sections that we're talking about so far, you can see that you need to do much work there on our mechanics and our electricity and magnetism. And last but not least, we have the section on matter and materials. Right. And here we're dealing basically with the optical phenomena, right? Where we're saying you should be able to describe the photoelectric effect. We've got terms like the threshold frequency. Yes, do you still remember what the threshold frequency is? And are you able to do the calculations there? Are you able to define our work function? Right. So these are the sections that we find in our paper one examination, right? So in addition to these concepts, you'll find the topics that you did in your grade 10 and grade 11, that is your Newton's laws. Yes, we do not learn to forget. We still have to remember those concepts. Remember electrostatics, as well as the electric circuits that you also did in your grade 11. And I'm saying, by the time you reach your examination, we're saying all this information has to be in your fingertips. Are we together? In your fingertips. And as I said, let's take part actively and do these calculations in our lesson today. So those are the sections that you can look at, right? And we're saying, since our examinations are around the corner, yes, grade 12, I'm talking to you, since your examinations are by the corner, what is it that we expect of you? Okay, when you go to the examination room, can you bring all the necessary materials that you need for your examinations? And also, importantly now, when you are now in the examination room, carefully read the instructions, right? Carefully read the instructions. And remember, there is that preparation time. So when you're given the preparation time, what do? Go through the questions. Okay, when I say go through the questions, I'm not saying answer them. Just read through your question paper. And we're saying, what is the purpose of doing that? It is for you to actually be able to pinpoint the questions where you are likely to score a lot of marks. So that when they say start writing, you know which questions exactly that you want to start with. And that can save you time. Okay, because if you spend a lot of time on questions that you actually do not understand or you find challenging, you may end up wasting time. All right. And importantly, you need to arrive at the examination venue before the exam starts. Arrive on time. Okay. Right. Those are just a few tips for you to remember so that you can do well in the examinations. And yes, I do believe that you will do well in your examinations. Okay. That being said, let's start on our lesson for today. So we're having two sections in our paper one, right? Section A, we have the multiple choice section. I'm sure by now you know the structure of your questions, right? So in our multiple choice section, we have 10 questions, each carrying 2 marks, right? So we want to look at some typical multiple choice questions, but in the interest of time, we're only going to do just 2 questions, right? So our question says, right, let's work together, guys. Let's work together. Now, remember I said you're attempting these questions individually. Number 1, a physical quantity that is described as a measure of the resistance of a body to change in motion is called. So looking at that question, you realize this is a recall kind of question. And we're saying it's either you know the concept or you don't. Okay, so if you don't know, then you are in trouble. Therefore, it means you need to appreciate the terms that we use in physics. You know them, you internalize. And you agree with me that we're talking of a resistance of a body to change motion. Let's say now a body is already moving, okay? It has a resistance to stop moving, okay? And let's say a body is at rest. It tends to have a resistance to start moving while it is at rest. Are we getting that? Right? And you agree with me that is a concept of inertia. We're talking about a body's reluctance to stop moving while in motion. Okay? Think of a truck. When it is moving in high speed and for it to stop, think of a bicycle, okay? When it wants to stop. And you will see that the two have got differences in terms of their reluctance to stop moving or to start moving when they are actually at rest. So for this particular kind of questions, we are saying you should be able to recognize the facts, understand the concepts, okay? When we're talking of force, you remember we're talking of that which is needed to change a body state of rest or uniform motion in a straight line. Okay, that is a force. So you should know the definition. It's either you don't know or you know, right? Acceleration. the rate of change of velocity. So you should know these definitions, okay? Weight, you are talking about the measure of what? Of the force of gravity that is acting on a body. All right, so know these terms, master them, and you will not have challenges when it comes to tackling your multiple choice questions. So they were saying that is our inertia. Right, let's go to the second question. Right, so we've noted that our multiple choice questions are tricky in the sense that you need to get your facts on your fingertips. Right, so that is your assignment, grade 12. Are we together? I want to hear yes there. Are we together? Say yes, sir. Okay, all right, now let us proceed. Now, in the diagram below shows a section of a path of a stone projected vertically upwards. So you can see there it is thrown vertically upwards from point 1. It goes through point 2, point 3, and point 4. Then at which one, okay, always take note of the words that are put in uppercase, okay? Those are a sign that you should take note of the statement there. At which one of the positions indicated on the diagram will the magnitude of the momentum of the stone be greatest? Okay, greatest. Ignore air resistance. So we don't consider our air resistance. Right, so we're talking of momentum. That is the thing that you should understand. What is momentum? The product of the mass and the linear velocity of an object. So our momentum, we know that it's mv, right? And we're throwing a stone, so we understand that our mass there is actually constant. It does not change, all right? So what is changing is the velocity. And since it is the product of the mass and the velocity, what does it mean? It means now the bigger the velocity, the bigger our momentum. So the question is, where is your velocity greatest? Is it at point 1 when it is moving, right? So when it is launched up, we agree with, because of the acceleration due to gravity, which is negative, right? We know that as the stone rises, its velocity is going to drop. And when it is at the maximum height there, it becomes 0. And consequently, it means our momentum is going to be 0 at point 2. So our point 2 definitely is off, okay? And then we come to point 3. I want you to take note of something. Point 3 and point 1, right? When your stone passes through that point there, it will be having a velocity equal but opposite to the initial velocity at point 1. All right, so when it passes that point, it means we have an increase in velocity, meaning the velocity at point 3 is going to be higher than the velocity at point 1, and as such, the momentum, therefore, is going to be higher at point 3 than at point 1. I hope that makes sense. And you proceed going further downwards there, we have an increase in velocity going further down, and therefore, it has got an impact on our momentum, and therefore we're saying our momentum is going to be greatest at point 4, making our solution then point D. Right, so you understand that for you to get your multiple choice questions, you need to work on your facts, get your facts right, whether it's calculations, whether it's laws, formulas, get them right and understand your concepts. So we have 10 questions there in the multiple choice questions. And then another point you note, do not leave the multiple choice question unattended. Answer all, okay? If the worst comes to the worst, make an intelligent guess, okay? Don't leave a multiple choice question unanswered. You never know, your guess might be right. Right, okay, now we want to proceed to the second section, that is section B, right? In the interest of time, we're just going to focus from question 2 to question 4. Right, now I want us to look at this question this way. Take note of how we'll be attempting these questions, okay, grade 12s, and master this method so that you can do it also when it comes to your studies. Number 1, if you want to pass your examinations, be guided by the examination guideline. Take note of that, right? Be guided by what? The examination guideline, right? So when you look at your past examination questions, grade 12s, the first thing you should know each question that you have in your sections is part of a particular section. So you go to your question. For example, I go to question 2 of our paper 1 and I take note. Okay, question 2 is Newton's laws, right? So what do? You go to your examination guideline, right? And let's go through what you are expected of in question 2. Take note of these. Can you mark them down and use them to actually prepare for your examination? So in question 2, these are the points that you'll be expected to know, right? Number 1, you should be able to define a normal force. Take note of that. Am I able to do that? If not, internalize this definition. Define a normal force. And this is in accordance to the examination guideline. Right. Number 2, are you able to define a frictional force? Are you able to define static friction? Are you able to define kinetic friction? I can hear others are saying yes, yes, yes. And if you are saying no, 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 take note, master these definitions. These are the definitions that you can expect in your question 2. Is that clear? Yes, sir. Okay, is that clear? I can hear you saying yes, sir. And then in addition to that, what is it that you are expected to know in question 2? You should know that the frictional force is proportional to the normal force. I hope we still remember that equation, coefficient of friction multiplied by the normal, that gives us our frictional force. And then also, it is independent of the area of contact. It is independent of the velocity of motion. We're not going to dwell much on that. I know you've done it. Right, then also in your question 2, you may be expected to do your force diagram or free body diagrams, right? You should be expected to draw force diagrams, to draw your what? Your free body diagrams, right? And then also you should be able to resolve two-dimensional forces. So if you are given a force that is two-dimensional, are you able to calculate its horizontal component? Are you able to calculate its vertical component? That is resolving your forces that are in 2 dimensions. And therefore, you're also expected to determine the resultant or net force of 2 or more forces. So these are the sections that are actually catered for in your question 2. Right, and to get more information, you can check your KEPS document, pages 62 to 66, so that you know when you're opening your paper, question 2, you know that I'm covered. I've done all the possible questions that they can ask. Right, I hope that makes sense. That being said, let's look at a typical question 2 type of question. As I said, I'll give you time in some of the sections. You attempt them. Yes, you attempt them individually, and then we go over it together so that you can make your corrections. Right. So let's go over this question together. I'll read through, you follow through, and we go over it together. Now, a 20 kilogram block resting on a rough horizontal surface. Something is telling us it's rough, therefore there is friction, right? And it's a 20 kilogram block, right? Is connected to blocks P and Q. We can see there is our 20 kilogram is connected to blocks P and Q by a light inextensible string, so it cannot stretch, right? Moving over a frictionless pulley. We can see the diagram there. Blocks P and Q, they are actually glued together, having a combined mass of M. Everything you can see there on the sketch, right? Now, a force of 35 newtons, there is a force of 35 newtons, is applied on the 20 kilogram block at an angle of 40 degrees. We can see it there. Right, we're talking about the forces there that are in 2 dimensions. You should be able to resolve. Remember that section from our exam guideline. Right, with the horizontal as shown below. Now, the 20 kilogram block experiences a frictional force of the magnitude 5 newtons. Right, as it moves to the right. So already it's communicating something. It's moving to the right. So in which direction is our frictional force? Obviously, it goes to the left. Friction opposes our motion. Now, at a constant speed, remember the capital letters, okay? At a constant speed, constant speed means zero acceleration. So we've got a lot there from that statement. First part, define the normal force. Remember, I say this is a past examination question. It's one of the definitions, one of the key terms you need to know how to define over the list that I also told you about. So ensure that you know all those definitions that I gave you. Then part 2, draw a labeled free body diagram, 5 marks. Okay, so now let's start with the first part. Define the term normal force. I'm going to give you the definition, right? And I hope by now you're actually seeing it, right? So the normal force is that perpendicular force which is exerted by our surface, okay? The force exerted by our surface on an object, okay, in contact with the surface. Take note of the underlined section. It has to be perpendicular, okay? It's a perpendicular force. It is at 90 degrees, okay? And it is exerted by the what? By the surface on the what? On the object that it is in contact with. So take note of the underlined sections there. And if you write that, you get your 2 marks, right? The next part then, draw a labeled free body diagram on the 20 kilogram block, on the 20 kilogram block, right? On that part, I'm just going to give you 5 minutes for you to draw that diagram. 5 minutes starting from now. Right, welcome back, welcome back. I hope grade 12s, you are finding this quite easy. Right, so we want to draw a free body diagram. The word free body means free of the body. Okay, so we want to show all the forces that are acting on our 20 kilogram block. And remember, the forces have to be pointing away from the center. Okay, so let's identify the forces that act on the 20 kilogram block. Number 1, we have the weight of the block itself. So the free body, remember, we are using a dot to represent our object, and we're saying we have the weight, and we label it W. We label it accordingly as W. What else do we have? We have our normal reaction force, okay, which will act perpendicular, okay, and we're saying that is our normal reaction force, and we're using the symbol capital letter N, right? And remember, when you're drawing your free body diagram, you are isolating your body, okay? It's like you're concentrating on it and forgetting about the rest of the system. We are concentrating on the 20 kilogram block. Is that making sense, grade 12? Key importance, remember I said, we are using a dot to represent our object. So you come here, you realize there is another force. And which force is that? Which is pulling it going that side. That is our tension. Okay, so you label it with the letter T. Right. And then what else do we note? Remember we said it is moving to the right. It is moving to the right on a rough surface. So if it is moving towards the right, the friction is moving towards the left. And therefore you represent your friction there with your letter F. And last but not least, we have that force. Remember the 2-dimensional force that is acting there at an angle. Okay, and we are going to label our force F. Right, and I'm sure that you are able to get that free body diagram. And as such, we can say these are indeed free marks. Take note, 1, 2, 3, 4, 5. 5 marks. Okay, so we are representing using our arrows, and we get our full 5 marks. So remember, this is what we expect in our question 2. Let us continue with our question. Right. So let's continue and hear what the question continues to say. Let's read through it together. Now, the 20 kilogram block experiences a frictional force of 5 newtons. Remember, we spoke about that. As it moves to the right at a constant speed. Now, calculate the combined mass M of the 2 blocks 5 marks. We need to get the combined mass M of the two blocks. Right? For this part, I'm going to give you another 5 minutes starting from now. 5 minutes. Right, welcome back, welcome back. Now, we need to calculate the combined mass of the two blocks there, that mass M, right? So, for us to get that mass, there's something that we need to understand. How can we get the mass M? We need to apply our Newton's second law, right? If you are to isolate this object P and Q, you realize that P and Q have a particular weight, which I'll call mg, which is pulling going down. And up there, pulling going up, is our tension T, isn't it? So for the resultant motion, okay, for the resultant movement of this object P and Q, we're saying for that to occur, there is a difference between the tension and the weight of our object. Okay, and that should be obviously now equal to the product of our mass and the acceleration of our object G. So you realize that for us to obtain our mass there, we need actually to obtain our tension T, the tension that is there in the string. Right, I hope that is the approach that you actually took. Right, so for us to obtain the tension in the string, let's start by looking at the 20 kilogram object then, right? And I want us to resolve our forces, okay? The horizontal forces that are actually acting on the 20 kilogram block. Can you identify them? Okay, one, we have the tension which is pulling towards the right. Okay, and we'll say towards the right is our positive and towards the left is our negative. Take note of that. Always try to take your east as positive to make your calculations quite easy. Right, so opposing the forces, the tension, what else do we have? Remember, we have our friction, our frictional force, our kinetic frictional force, which is going towards the left. And then we have the resultant. Remember, you need to get the component there. We call that our F. And therefore, it means we need our horizontal component, which I'll call Fx, which is going also to the left. So it is the frictional force and the horizontal component of our force F, which are opposing the tension there. And that obviously is going to be equal to the mass and the acceleration of our object, 20 kilogram object. I hope you're taking note of that. So we say to the right is positive, therefore our T is positive, and therefore it makes our friction and the resultant X component of our F there, making them negative. I hope that is making sense. So now we can substitute those values. Remember, our frictional force, we're told, is 5 newtons. Okay, and now if we were to resolve the horizontal component there of our force F, we're going to realize it's going to be 35 cos 40. Remember your trig ratios there from your mathematics. Okay, so 35 cos 40, that is our resultant horizontal component of our force. Okay, and we're saying this is equal to 0. Where is the 0 coming from? We're coming from there. Okay, remember our mass is 20, but our acceleration is going to be 0. Why is our acceleration 0? It is because we're moving at a constant speed. I hope that is making sense. And now, given that, we can solve there using our calculators, and we get a tension of 31.81. I hope that is making sense. Right. So now, when we are at this stage, we now look at our object PQ there. We isolate it. Okay. And we're saying for there to be movement going to downwards, remember, is to the right, and then the resultant movement is going down. There has to be a resultant of the weight and the tension in the string. And we're saying that also gives us the net force, which is equivalent to the mass times the acceleration of PQ. Right. So what do we do there? And then we're saying there, what is our mg? Remember, we need to get the mass. Okay, we need to get the mass of our object, PQ, and we're saying multiplied by g, that gives us the weight. Okay, so remember, we're still maintaining now the direction, the downward direction, that will be our positive, and the upward is our negative, which makes our t negative. So we're saying the weight minus the tension gives us the mass times the acceleration of our object at that point. So we can substitute now. Our t is 31,81 from our calculation there, right? And then we can now solve for our mass, and that gives us a mass of 3,25 kilograms. I hope we're all able to do that calculation. All right. So at this point, I'm just going to give you a minute for you to copy down the calculation.